see what happens. Okay. Okay. So does everybody have, is this like a textbook, Jill, that you sent me?
Yeah, it's like our ATI chapter.
Okay. So
yeah, it's a PDF of a textbook.
Okay. Okay. So the first thing that I want to talk about are basically just some tips and tricks as you guys work through these problems. And I'm going to do some behind me, so hopefully everybody can see that. And I'll try to write really thick with my marker because I kind of have a crappy webcam. I almost did this on my phone, but anyway, it's just easier on the webcam. I got a better angle. Okay, so first thing is there's a lot of extra information that you don't particularly need to know in order to like do the problem. So like the route that you're giving a medication, even how often you're giving it. Of course, whenever you're nursing, that's going to be important, but to just do the conversion, we're going to stick to finding what you know, a conversion factor, and what you need to know. And then at the end, like look at it and does it all make sense? Okay. So like all that other stuff is just extra in those problems. I mean, it's not extra, it's obviously important for nursing, but as far as just getting the math done, you don't need to know all that. Next thing, when we talk about ratios, because that's what conversion factors are, like on this first page, the standard conversion factors, I don't know what page number this is because I don't have it on here, but hopefully you guys can see that because I just have pictures that Jill sent me. But those are simply ratios. So I know this is really cheesy, but think about ratios like a married couple. It doesn't matter what side of the bed they sleep on. They might sleep on, the wife might sleep on the left side one time and then the right side the other. It doesn't matter, but they're always together. So when we talk about conversion, like the first one, 1 milligram or 1 milligram is equal to 1,000 micrograms. So 1 milligram, I hope you can see that, and 1,000 micrograms. When we're writing that as a ratio, it's not a fraction. They stay together. So it doesn't matter. That's the same thing when we talk about ratios as saying, I could put 1,000 micrograms on the top and leave 1 milligram on the bottom. Okay, so a lot of times students think, oh, well, that's a fraction, like you can't flip-flop them. When it comes to ratios and conversion factors, they're married, they're always going to be together. Sometimes they just will sleep on one side of the bed or the other side of the bed. That's how I describe it to my students. Okay, next thing is whenever we're going through these problems, we're going to identify what we know, what if there's a conversion in there, and then what we need to know. What you know always goes first in any conversion. So I'll go back and kind of talk about that. Okay, cool. And down at the bottom, there's like reactions. If you're on Zoom, you can do a thumbs up or whatever if you guys aren't in a video. But yeah, I'm recording this too. I saw Heather, I guess, is leaving because I'm going to record it. Okay. All right. You can see this board okay and hear me okay? I don't usually do this when I teach.
Yeah.
Okay, because I don't teach.
It looks good.
Okay, great. All right. So the first one I want to do, and I don't know how I'm going to tell you this without page numbers. Oh, I want to go back to, I'm not going through the, okay. I don't like how this is set up because they show you 3 different ways to get the answer. So using ratio and proportion, using desired over have, and using dimensional analysis. I'm just going to show you dimensional analysis. They give you too much information in here. No wonder you guys are overwhelmed.
Can you do desired over have too? Because I feel like we use that a lot.
I could try, but let me do this first because it's what I know.
Okay.
I don't really know.
Sounds good.
One other thing I guess I should say, sorry, I talked to Rashonda while you were busy, but I should say this for anybody who records this, just so they know. First of all, I'm Chelsea Herndon. I work at Metro Technology Centers. I teach in the Biomedical Sciences Academy. I teach high school, and my students want to be in the medical field, so I teach them this stuff. But also, I work part-time for an emergency veterinary hospital, so I do dosaging like all the time. We have 1-pound dogs to 120-pound dogs, whereas in humans, it's a little bit easier than it is in animals. So not only do I teach it, I practically use this stuff. So there's that. Okay, so on our application exercises, do you know where those are? There are 8 problems. It's like there's not page numbers, I'm sorry, or I'd give you page numbers. But they're the 8 practice problems at the end. Sorry, I'm having to bend over to talk into this camera. Can you still see my?
Yeah.
Okay, so I want to start with number 4. Do you see that one? I don't know how you say that drug because it's not a veterinary drug, but metoprolol. Metoprolol. You with me?
Yeah.
Rashonda, you good?
Yes.
Okay. Application exercises number 4. I want to start with that one. So first of all, I want us to identify what we know with a circle, and I know this sounds cheesy, but it's just the easiest way to do it. We're going to identify conversion factors with a CF. Can you see this okay?
Yeah. There's kind of a glare.
Okay, you want me to turn my lights off?
Yeah.
Is that better?
Yeah, that's better.
Okay. And this is what we need to know, or the question. So basically, anytime you're doing a problem, circle what you know, write CF, or if you want to come up with some other way to do this, that's fine. And then a question mark next to what you need to know. Okay? Hopefully that makes sense. So I'm just going to read this out loud and then work it out with you. A nurse is preparing to administer metoprolol, 200 milligrams PO, which means per ounce or by mouth, daily. The amount available is metoprolol, 100 milligram tablets. How many tablets should the nurse administer? And then it tells you to round, which I hope everybody knows mostly how to round. But I mean, I guess we can go over that if we need to. So first thing, what do we know in that problem? Like, what do they want to give, basically? It's a given. You know? You want me to tell you? Okay, so they need 200 milligrams. That's what we know. I'm going to circle that. So whether it's, so it says it's given PO and daily. Again, I know that that's important when it comes to nursing, but just for solving this math, I don't care. What I care is I know that they need 200 milligrams. Okay, what I want to know is how many tablets, right? That's my question. How many tablets are there? Sorry, I'm going to let Gladys in. Okay, so you always start off, and then the next thing is a conversion factor, and sometimes you need a conversion factor, and sometimes you don't. So like I have milligrams, and it tells me that the tablets are 100 milligrams per tablet, right? So that's my CF, or my conversion. There's 100 milligrams in one tablet. Remember, that's a ratio. I don't care. I could flip-flop that. It's not a real fraction. It doesn't matter. It means the same thing. One tab is 100 milligrams. 100 milligrams is one tab. They can flip-flop back and forth all that they want. So that's my conversion factor. That's what I need to know, and that's what I already know. So back in the beginning, I said you always start with what you know. So what we know is 200 milligrams. Okay, so I know 200 milligrams.
Gladys, I was going to tell Gladys.
Yeah.
Can you hear me? Hey, Gladys, we're on number 4, on the 1 through 8 problems. That's what she's explaining. Okay, sorry. Go ahead.
No, you're fine. Also, I don't mean to be like critical, but the first one on those application exercises is like one of the hard ones. Just in teaching, you never start with the hard one. You start with an easy, get the brain warmed up. So I would have given up after number 1 if I didn't know what I was doing. So that's why I'm starting with number 4. It's the easiest one out of the 8. Okay, so we know 200 milligrams, that's a given. It says that's what the patient needs. My conversion factor is 100 milligrams is 1 tab. What goes up must come down. So I like to use these little catchphrases. So, okay, bye, Rashonda. It'll be recorded. So again, a ratio, they're married. They can go on either side of the bed. It doesn't matter. And what goes up must come down whenever we're setting up dimensional analysis problems. So if what's up here is milligrams, because that's the top, you can always assume that's the top. The same thing has to be at the bottom. What goes up must come down. So what am I going to put at the bottom? Am I going to put 1 tab, or am I going to put 100 milligrams? Come on, Jill.
I'm taking notes. Okay, wait, what?
100 milligrams, because what goes up must come down. Okay? And then remember, they're married. They're going to stay in the same bed. It doesn't matter which side of the bed they're on. So that's 1 tab. So that tells me I need to, first of all, I could cross these off if I wanted, and that's just going to leave me with tabs. So that's a big hit. So I have 200 divided by 100. What's that answer?
Okay.
200 divided by 100. So I could do this. 200 divided by 100. Tell me, Jill. Gladys, tell me.
Shit. Hold on.
And I'm using black.
Can you see me?
No. No.
2?
Yeah, 2. So 2, and what's my only unit that's left? I circled it. Tabs, right?
Yeah.
2 tabs.
Okay, because those cross.
So then
Okay.
always at the end, I'm gonna write over here, I want you to ask, does it make sense? Because let's be honest, does it make sense? At the end of the day, you're nursing, right? You could do this math all day, but like, does it make sense? So if I read this problem, a nurse is preparing to administer this drug, 200 milligrams PO daily. The amount is 100 milligram tablet. Okay, 100 milligrams. Are they going to get more than 100 if they have 200? Yeah, right? So then they're going to have more than one tablet because they need 200 milligrams. One tablet is 100 milligrams. So each tablet's 100 milligrams. At the end of the day, they're going to need 2 tablets. So that's your answer for number 4 on the application exercises. It says round to the nearest whole number. We're already there, 2. So this answer is 2. So again, I just want to teach you some of my little like tricks. Circle what you know in the problem, figure out what the conversion factor is, put a question mark next to what you need to know, and then at the end, ask, does it make sense? You always start with what you know. I guess I should put that in parentheses. And at the end, you always ask yourself, does this make sense? If this patient needed 200 milligrams and each tablet is 100 milligrams, he's going to need more than one, or she's going to need more than one. So yeah, that makes sense in the end. Okay? Any questions, Jill? It's just you and me, so everybody left.
Oh, it is? Okay.
Yeah. I mean, I'm recording it, and I'll send it to you, but it's just you. Okay.
So that problem that you just worked out, you'd consider that the dimensional analysis way?
Yeah, I'm just going to be honest with you. I didn't really look at what they meant by desired over have.
I mean, it would just be literally be desired over have. You just set it up as 200 milligrams
divided by
over 100.
Yeah.
Huh?
And that's what this is doing.
And that's it.
This is doing too. I mean, it's the same thing.
Yeah.
Yeah. Okay. So now I want to just, but does my little like tricks make sense? Because that's really, I just want to do an easy problem with my tricks. Circle what you know.
Yeah.
CF next to what the conversion factor is. Question mark you need to know. There's somebody named iPhone who wants in. I guess I'll let them. And then,
okay.
Hi, welcome. And then at the end, just think, does it make sense? Okay.
Yeah. Okay.
This is number 4 on the application exercises at the end. Now I want to go backwards to injectable dosage, that problem. So the very beginning starts with solid dosage, and then liquid dosage, and then injectable dosage.
Okay. Is that on a different page?
Yeah, and there's no page numbers. Go backwards.
Sorry. Go to injectable dosage.
Injectable dosage, where they're like teaching you how to do it.
Okay. Okay.
Okay.
It's page 288.
Thank you. Write that down. Gladys is back. Page 288, the injectable dosage problem. So I'm just going to read it first. I'm going to try to get out of the way so you can still see that. Okay. So a nurse is preparing to administer heparin, 8,000 units subcutaneously every 12 hours. Available is heparin injection, 10,000 units per mil. How many mils should the nurse administer per dose? And then we'll talk about rounding at the end, because that's always how they get these, with how you round them. So remember, there's going to be extra information in there. You don't need to know that it's given subcutaneously or under the skin. I mean, you do need to know when you're actually doing it, but just to calculate the dosage, we don't care how much it's given right now either. Okay? All right. So first of all, I need to identify what I know. So in other words, what are the doctors need to give? Order. Like maybe I should say that. No order. What are they saying this patient needs? Jill, tell me. How many units?
10,000.
I was like background, so I don't Hope you're just, I don't know.
Okay,
I didn't hear
8,000.
everything.
You're like, I don't want to be your go-to student. Okay, so it says that they need to give 8,000 units. So that's what we know. So 8,000 units is what I know. I'm going to circle that. It's what the doctor ordered. It's what I know. It's what I'm going to start with when I do my problem. I need to administer 8,000 units. Okay, the next thing is the conversion factor. So it tells you how many units are in a mil right there in the problem. It says there are 10,000 units in 1 mil, right? So the CF, or the conversion factor, 10,000 units in 1 mil. Okay, again, I'm going to keep saying this to drill it in your heads. This is not a fraction. This is a ratio. These can flip-flop. They're married. They sleep in the same bed. They can sleep on whichever side of the bed they want to sleep on as long as they stay together, which they're going to stay together. They're never getting divorced in a ratio. Okay. The next thing is the question, or what are we needing to know? And it says, how many mils should the nurse administer per dose? So the question that I need to know is how many mils? That's what I need to know. Again, everything else is just extra for my math. So I'm always going to start with what I know. So what I know is 8,000 units. I'm always going to start with that. What goes up must come down. So this unit is on the top. Whenever I'm doing dimensional analysis, what goes up must come down. Remember, this ratio can flip-flop any way. So I need to bring that unit to the bottom so I can cancel this unit out. So when I write this conversion factor, it's going to be 10,000 units on the bottom and 1 mil on the top. Again, that ratio stays together, can flip-flop either way. What goes up must come down. So what that's telling me is I can cancel out units. I can cancel out units. That's going to leave me with milliliters. Isn't that the question? How many mils? That's the whole end result. That's why we're doing it, right? So in the end, that's saying 8,000 divided by 10,000. If you can't do that in your head, use a calculator. But your answer should be 0.8 mils. Okay, so always at the end, I want you to ask yourself, ask somebody working in the health field, does this make sense, right? If you're taking care of my mom or dad, I want you to really check yourself at the end, does that make sense? So if in 1 mil there's 10,000 units, that doctor has ordered 8,000, that's less than 10,000, right? So I should know, okay, yeah, I should be giving less than 1 mil, that makes sense. He ordered less than the amount that's in 1 mil, okay, less than 1 mil, that makes sense. Because I'm saying if you flip-flop this and you do this backwards and you do 10,000 times 8,000, and heparin is a blood thinner, you're going to kill somebody. So that's why I keep saying at the end, does it make sense? Okay? Got it? Okay, so those two are pretty easy. Those are kind of one-step dimensional analysis. That's why I kind of wanted to start with those, but I know they get more difficult. So I'm sorry I'm flip-flopping, but go back to the application exercises. What page is that, Jill?
It's, hold on, page 294.
Okay, thank you. Sorry, I'm just going off pictures, so I don't have page numbers. Anybody watching? Okay, I'm gonna erase this. Get on this video so you can rewind it or whatever. Okay. So I already did number 4. Can I hop around, or do you just want me to start on number 1?
Yeah, it's fine. Do whatever.
Okay. Let's do number 2.
Okay.
I'll just tell you, like, when I was working these out, this is really ugly. When I was working these out, 1, 3, 5, and 8 are the hardest. So I'd rather kind of like do those at the end. So
okay.
Let's do number 2. Okay. So number 2 says a nurse is preparing to administer lactated ringers, IV 100 mils over 15 minutes. The nurse should set the IV infusion pump to deliver how many mils per hour? So what we know is that nurse needs to give 100 mils over 15 hours. And that's what we know. I'm going to circle it. Okay. The question at the end is, how are they going to set that IV pump? Because IV pumps are in mil per hour. So how are we going to set the IV pump? So in the end, they want to know how many mils per hour are we going to set that IV pump? Okay, so this is one that you're just going to have to know. We are going from minutes to hours. So they're not giving us the conversion factor in the actual problem, but we all know how many minutes are in an hour, I hope, right? So my conversion factor, my CF or my conversion factor is going to be, there are 60 minutes in 1 hour, right? At the end of the day, they want mils per hour. They're giving it to me in minutes. That doesn't work for me. I need to know the conversion factor to get what they need. So I know, just because, you know, I'm a grown up, there's 60 minutes in 1 hour. Okay, so we always start with what we know. So if there are 100, let me see what I did here. Okay, 100 mils. I'm trying to see if I did this somewhere else on here because I worked these out different ways. In 15 minutes, I want to get rid of that minute. So really what I need to do is flip-flop this. You could probably do it like this. Hang on. No, this is fine. This is fine. Okay. So what goes up must come down, or the opposite. So my conversion factor, I want to cancel out this minute and turn it into hours. So what goes at the top here? 60 or 1. Look at this conversion factor. What goes at the top? I want to cancel out this minute. What goes up must come down.
60.
Yes. So 60
on top, right?
60 minutes, 1 hour. That's going to get rid of minute, get rid of minute. That's going to leave me mil per hour, which, what do you know? That's what they're asking me to do, is set that IV pump at mil per hour. So what I do is I do 60 times 100. So 60 times 100, I just had 2 zeros. You can use a calculator if you want. That's 6,000. And then I need to divide that by 15. So if you have a calculator, you can use a calculator, because I couldn't do that in my head. But the end result, 6,000 divided by 15, is 400. What's my unit? What do I have left? Mil per hour. So at the end, we're always going to say, okay, does this make sense? So the doctor wants 100 mils in 15 minutes. I got to set this so this person gets it in 15 minutes, but my IV pump only has settings for hours, because they do in veterinary medicine and human medicine. I think, I don't know human medicine, but they do. So I got to set this. So I need this to be faster, right? So I need it to be set for 400 mils in 1 hour, because basically if I divide that, then it's going to get me to my 100. If I divided it by 4. Tanisha wants in. Sorry, I got to let people in as they come in.
No, you're fine. I'm going to probably try to get it on my computer.
Okay, so again, we are on page 294. I just did question number 2. We circled what we know, or the doctor's order. That's always what we start with. We figure out, what are they asking me to do? They're asking me to set this IV pump. We figure out what the conversion factor is. Sometimes it's given. Sometimes I just need to look it up, or I know it. I know there's 6 in 1 hour. Okay, you have to identify those 3 items before you can even set it up. We always start with what we know. What goes up must come down. You cancel out units, do your math, and that's what you're left with. So at the end, you always ask yourself, does that make sense? If he needed 100 mils in 15 minutes, then he would need 400 mils in 1 hour. Jill, you might mute one, maybe mute one or the other.
How do I do that? Okay, never mind.
Third, you're gonna have to mute your actual computer too, because it's gonna pick up your mic on your computer.
How do I do that?
Mine is like the speaker in the bottom right of my actual computer. Where there's a sound. You're echoing. Or you can get off the computer and stay on your phone. Or Your computer is like picking up your phone.
Here, screw it. I'll just do it on my phone.
You're good. I think you're good now. Okay. We did 2. We did 4. I'm saving the harder ones for last. Let's do. Any questions about that? Does this make sense?
Yeah, after I go back over it.
Okay. And I can help you again. Okay. Erase that. If you just get the tricks of figuring out what the doctor's orders are, identifying the conversion factor, figuring out what the question is, what goes up must come down, and ratios can be flip-flopped. They're not actually fractions, they're just ratios. Those are the big ones. Okay, let's do number 6. Number 6 again.
I got a question.
Yes.
So on the ratios, like the conversion factors, you just mean like, 1 gram equals 1,000 milligrams. Is that what you mean by all those that are like already given?
Yes.
Do you know what I mean?
Yes. So 1,000 milligrams is 1 gram. That's a conversion factor written as a ratio. So that is the exact same.
And you'll always write it like that when you're setting these problems up. It's just always whatever the unit to unit is, you're just always going to set it up like a ratio.
Yes, always.
Okay.
Conditional analysis.
Oh, okay.
So this is the exact same thing as saying 1 gram is going to stay married to 1,000 milligrams. They're always going to be married. They're going to stay together forever and ever and ever. They don't believe in divorce. Sometimes they sleep on another side of the bed. That's it. You can flip-flop them all you want. Okay?
Okay.
Okay. Page 294, number 6. So it says, a nurse is preparing to administer dextrose 5% in water, 1,000 mils IV to infuse over 10 hours. The nurse should set the IV infusion pump to deliver how many mils an hour? So this is just like what we did before. Okay, so, sorry, I have notes all over this, so I'm making sure I didn't add anything extra for this problem. So what we know is that they want us to do 1,000 mils in 10 hours, right? That's what the doctor's asked. 1,000 mils in 10 hours. So what I know is 1,000 mils in 10 hours. I'm going to circle that because I know it, and that just helps me stay nice and organized. You could circle it actually on in your book if they'll let you. I don't know if they'll let you or not, but okay. What we want to know, or the question, is how many mils per hour. I'm just going to start writing it like this, if that's okay. That's my question. So now I need to decide, is there an actual conversion factor here? So they're giving it to me in mils per hour, and they want it in mils per hour. Is there a conversion factor that I need? Do I even need that step?
Don't ask me. Okay.
It's hard to teach when nobody talks back to me. I'm not used to this. Okay, so I'll just.
Yeah.
Okay, so they're giving it to me in mils per hour. They're asking for it in mils per hour. So I don't have to bother with any sort of conversion factor here. So this step, the CF step, it doesn't exist. Remember the last problem we did where we had to take hours into minutes, or minutes into hours, I'm sorry? We don't have to do that, okay? Because it's already done for us. So literally all you have to do here is the math. That's it. So on that one, all I'm doing is 1,000 divided by 10. Hopefully we can do that just with the zeros. All I do is cancel out my zeros. So my answer is going to be 100 mils per hour. That's your answer. Conversion factor, that one's super easy. So remember, always, if you're in the health field, always say, okay, does that make sense? All right, if over 10 hours, they're going to get a whole bag of fluids, because a bag of fluids is 1,000 mils, right? If over 10 hours they're going to get that, then in 1 hour they're going to get 100. Okay, that makes sense. If it was flip-flopped, if you're saying they're getting 1,000 in 1 hour, that's a problem. Very rarely are we going to push a whole liter of fluids. They have to be really dehydrated before you're going to do that. Okay? Okay. It's number 6. Let's do number 7. So again, page 294, application exercises. I'm kind of jumping around because I want to warm us up to do some of the harder ones. Okay, number 7, a nurse is preparing to administer acetaminophen, which is Tylenol, 320 milligrams PO per os, which means by mouth, every 4 hours. PRN or as needed for pain. The amount available is acetaminophen liquid, 160 mg in 5 mils. How many mils should the nurse administer per dose? So the first thing is I need to identify what I know or what's been ordered. So what's been ordered is 320 milligrams. That's what I know. So I'm going to write down 320 milligrams. That's what they're asking me to give. I'm going to circle it. How often it's given is not necessary. I know it says every 4 hours in PRN, but really I don't care about that in this problem. Okay, that's what I know. The next thing is what do I need to know? And it tells me at the end how many mils should the nurse administer per dose. So my question is, how many mils? Now I need to figure out the conversion factor, and in this one, it's given to me. So the conversion factor is given to me, and it says 160 milligrams is in 5 mils. And sometimes you'll see that on oral medications. It's by 5 mils because we like to dose by teaspoon, especially with little kids. But typically, we want to turn that into just 1 mil, right? So if I wanted to turn that into 1 mil, what would that be? How would I do that? If I wanted to find out how many milligrams is in 1 mil, I just do the math to reduce that. Okay, so 5 goes into 160, 32 times. So my conversion factor is 160 milligrams and 5 mils or a teaspoon, but I need to know how many mils, not how many teaspoons. So I'm going to break that down. That's the same as saying there are 32, and I just did the math before. I couldn't do that math in my head probably. There are 32 milligrams in just 1 mil. So that's my final conversion factor. So that's something you need to kind of pay attention to if they give it to you in, like a lot of times on injection bottles, it'll say like, 100 milligrams in 10 mils. Okay, well that means there's 8 milligrams in 1 mil. You've got to be able to break down your conversion factors, just reduce fractions. Okay, so we always start with what we know. I circled it. What we know is 320 milligrams. That's what the doctor's ordered. Then I need my conversion factor. What goes up must come down. Jill, what goes on the bottom? Oh, you're muted. Milligrams. So 32 milligrams in 1 mil. That's going to cross this out. I'm going to be left with mils, which is what I want. At the end, it's asking me how many mils. So 320 divided by 32, if you do the math, that's 10 mils. So in every problem, we need to identify what do we know, what's the doctor's order, 320 milligrams for this particular patient. What's the question? How many mils am I going to give this particular patient? What's the conversion factor? It was given to us, but it was given to us not reduced. It was given to us 160 milligrams in 5 mils. Again, 5 mils is a teaspoon, so it's just easy for, Tylenol. If you've ever given it to a kid, you give a teaspoon, right? Okay, we got to reduce that down. All I did was divide 5 into 160, and so that's the same exact thing as saying 32 milligrams in 1 mil. What I know goes first. What goes up must come down. I take my conversion factor. I put milligrams on the bottom. They're married. Doesn't matter as long as they stay together, which side of the bed they sleep on. Milligrams on the bottom, mil on the top. I cancel out my units. I'm left with mils. When I do the math, 32 goes into 320. I get 10 milliliters. So again, we always ask ourselves at the end, does that make sense? So if 160 milligrams is in 5 mils, I need to give 320. That's a lot more. So I know I'm going to be giving more than 5, right? So yeah, if I just doubled 160, that'd give me 320. So in other words, they get 2 teaspoons or 10 mils. So sometimes you can just do these in your head. Like for me, when I saw that, I'm like, okay, 160 mgs and 5 mils, they're going to get 10 because they're just doubling it. But you got to make sure that you understand the conversion factors. Okay, the last 4 I'm going to do are tough. These are the ones I circled. Okay. Y'all put something in the chat or say something if I'm going too fast or you don't understand. Sorry. so I guess let's just jump to number 1. Why not? Okay, number 1, a nurse is preparing to administer methylprednisolone 10 milligrams by IV bolus. The amount available is methylprednisolone injection 40 mg in a ml. How many mils should the nurse administer? Okay, so what we know, what the doctor's order is 10 milligrams. That's what the doctor's ordered. I don't care that it is IV, as far as just doing the math. I don't care. Of course, you care when you're actually nursing. I don't care that it's a bolus. I don't care about any of that. Okay, what I know is the doctor wants 10 milligrams of that. The conversion factor is given to me. The conversion factor says that there are 40 milligrams in 1 mil. That's given for me. The question is at the end, how many mils? So my question, how many mils? We always start with what we know. What we know is 10 milligrams, so that always goes at the top. What I know, what the doctor's ordered is 10 milligrams. I need to use that conversion factor, which I just found in the problem. What goes up must come down. Again, these are married, they're never getting divorced. They can sleep on either side of the bed. I'm going to bring 40 milligrams down to the bottom. I'm going to leave my 1 mil at the top. Those cancel each other out. If I do the math, that's telling me 10 divided by 40, right? And if you have a calculator with you, 10 divided by 40 is 0.25. My only unit left is mils. What do you know? It asks me how many mils. So 0.25 mils should be your answer. But if you notice at the end, it says round your answer to the nearest tenth. If you've ever given a kid medicine, going to the 100th is going to be really hard. This is an injection. If you've used a syringe, that's going to be really hard. So we need a round. So since there's a 5 here, that's going to round this to a 3. It's going to bump it up. So my final answer is going to be 0.3 milliliters. Always at the end, we need to ask ourselves, does it make sense? So if my doctor has said, I need to give this patient 10 milligrams, 1 mil has 40. That's a lot in 1 mil. I should know right off the bat, okay, he's ordered less than 1 mil, right? If 1 mil has 40, he's ordered, I say he, that's so sexist of me. He or she has ordered 10. I should know just practically that's going to be less. And in the end, it is less. It's 0.3 mils. Okay. Again, if you have a question, type it in the chat. Although I haven't really been watching the chat, so I might have to holler. Okay. No, nobody said anything really. Okay. So you have questions, just say something. You can like raise your virtual hand on Zoom or put something in the chat. Okay. Okay, that was number 1. Let's do number 3. Again, on page 294, application exercises. I'm ending with the harder ones. Okay, the question says, a nurse is preparing to administer 0.9% sodium chloride, 250 mils IV to infuse over 30 minutes. The drop factor of the manual IV tubing is 10 GTTs per mil. The nurse should adjust the manual IV infusion to deliver how many GTTs per minute. I'm just going to be honest, I'm not familiar with this GTT thing. I'm assuming they're not using IV pumps, they're counting the drops. Just based, do you guys know? Do you know, Jill?
I have no idea.
Okay, that's kind of what it
I
says.
haven't done this stuff in years.
Okay. It says manual IV tubing, so I'm guessing that's what it means. But I mean, do people really?
Yeah.
Anyway, okay. I digress.
What number is this?
Number 3. Number 3, page 290.
Okay.
Number 3, page 290.
Okay.
Okay, so first of all, we need to figure out what we know. What we know is the doctor has ordered me to give 250 mils over 30 minutes. It's like construction or something going on. Sorry, it sounds like somebody's on my roof. Okay, so what I know is they want me to give 250 mils, and they want that over 30 minutes. I'm going to circle it because that's what I know. The conversion factor, it tells me my conversion factor, or my CF, is 10 GTT per mil. Again, they're married. Those can flip-flop whenever I go to actually solve the problem. And the question wants to know how many GTT per minute. Okay, so what I know is 250 mils over 30 minutes. My conversion factor I have right here. What goes up must come down. So at the bottom, I'm going to keep mils at the bottom. So I'm going to keep that 1 mil at the bottom, and I'm going to put 10 GTT at the top. That's going to cancel out my mils. That's going to leave me GTT per minute. Those are the units that are left. What do you know? That's the question. How many GTTs per minute? Now I just do the math. So 250 times 10, I just add a 0 in order to do that. 250 times 10 is 2,500. 30 times, there's an imaginary 1 here, divided by 30. If I do the math, again, I did this with a calculator earlier. I don't have this memorized. But if you have a calculator, you can do the math. And I actually think it works out to be a 8.3 or 83.3333 if anybody's doing it by calculator. But it says to round to the nearest whole number. So I'm just going to drop that 0.333. It's not bigger than a 5. So my final answer is going to be 83 GTT per minute. Get out of the way. At the end of the day, I need to know, does that make sense? They want me to give 250 mils in 30 minutes at this rate of 10 of these, right? So in 1 minute, I'm going to have to give 83. And I think that just means like drops, if you're counting the drops in a minute, if you're manually doing a ID set. So again, we identify the order or what we know. We always start with that. We identify the conversion factor. Either it's something you have to have memorized or they give it to us in the problem. We identify what the question is. What goes up must come down. And then at the end, you always ask, does that make sense? Okay, that's number 3.
A question.
Yep. Sorry, I'm trying to stay out of the way.
Hey, I got a question.
Yep.
Okay, your what goes up must come down thing. Okay, so like explain that. Like explain like exactly what you're doing there. Like what must up was your conversion factor what always must come down? Is that what you're saying? Or like
whatever
does that make sense?
Whatever's here on my order, my doctor order, what I know, has to come down. So I need to decide what am I.
What'd you say again? I hear you.
On my doctor's order, what the doctor has ordered right there, whatever is up. Okay, I'm on Zoom teaching. Do you need me? No. Okay, come on in. So whatever is up must come down in order to cancel out those units. Thank you.
Okay, so whatever's up must come down, and just make sure that's the same unit that comes down so they can cancel out.
Exactly.
Okay.
Must come down. So this is what I know. I need to make these match up. What goes up must come down. So that's why I'm saying I could flip-flop this, which we had to do in past ones, because what was here, I need to make sure is down here. If I wrote this conversion vector, if I wrote it, instead of writing it like this, if I wrote it opposite, which I can, if I said there's 1 mil in 10 GTTs, which again, I don't even know what that is, what goes up must come down. I'm going to have to flip-flop that, put mil at the bottom and 10 at the top. What goes up must come down. So the mil has to be at the bottom in order to cancel it out.
Okay.
That's kind of.
I'm on the same page now.
Okay. Okay. Let's do number 5. I'm trying to use black because I feel like you can see it a little better. Okay, number 5, again, page 294, application exercises. A nurse is preparing to administer ketorolac, I don't know how you say that, 0.5 mg per kg IV bolus every 6 hours to a school-age child who weighs 66 pounds. The amount available in that injection is 30 mg per mil. How many mils should the nurse administer per dose? And then it tells me to round. So what I know, and there's a few things I know. Oh, I gotta get my hood off. What I know here is the doctor has ordered 0.5 milligrams per kilogram. I know that. I also know that this child weighs 66 pounds. Right? Does pounds work? The answer is no. Okay, so we know all this. I'm going to circle it. My conversion factor, it gives me, it says my conversion factor is 30 milligrams in 1 mil. Again, anytime that's by itself, you can assume there's a 1 there. There's 30 milligrams in 1 mil of this medication that I can't say. And then the question that it's asking me is how many mils? That's the question. So what I know is the doctor says I need you to give 0.5 mg per kg. I know that kid weighs 66 pounds. I know the conversion factor because it was right in my problem. It said that that medication is 30 milligrams in each milliliter. And the question it's asking me is how many milliliters am I going to give to that kid? So I need to, first of all, convert this kid's weight to kilograms. I always tell my students we're really snobby in America. I don't know why we use our own metric system like miles and feet and pounds, because you just have to convert it all the time whenever you're doing any math or science. So you're always going to have to convert pounds into kilograms. So there's actually a second conversion factor. And I have this memorized. I think it's on there for you guys. Is it? Maybe it's not. Oh yeah, it is. One, if on the very, I don't know the page number, but your standard conversions, you can see that right there. It says 1 kilogram is 2.2 pounds. So I have another one. 1 kilogram is the same as 2.2 pounds. So there's actually 2 steps to this problem, which is why it's kind of at the end of my session here today. Okay, I can't work with pounds in medicine. I've got to change it to kilograms first. So what I know, the doctor wants 0.5 milligrams per kilogram of that medication. I know the kid weighs 66 pounds. I should automatically be triggered in my brain. That's not going to work. I'm going to have to turn that into kilograms every time you do a dose. The conversion factor is given to me at 30 mg per mil. I have this one memorized. I know 1 kilogram is 2.2 pounds, but again, it's in on the front page of this chapter 48 in your book. It tells you your standard conversions. Okay, the question that's being asked is how many mils? So first thing I need to do always is change my weight to kilograms. What do I know about the weight? I know that kid is 66 pounds. Here we go, Jill. What goes up must come down. If pounds are up here, pounds have to be down here to cancel each other out. 1 kilogram over 2.2 pounds. So I need that 2.2 at the bottom and my 1 kilogram at the top. What goes up must come down. That's going to cancel each other out. So that leaves me with kilograms per unit. That leaves me with 66 divided by 2.2. If you have a calculator and you're following along, that's actually a great measurement because it's an even 30 kilograms. So the first thing I have to do, this is a 2-stepper, is I got to turn that kid's weight into kilograms. So if you don't mind, because I'm going to erase this, 66 pounds is the same as 30 kilograms. So now I know that. Keep it in my circle. Okay, so I have to do that first. Anytime you're given a pound, you're going to have to change it to kilograms. Okay, so I need to figure out how many mils. By the way, I'm done with this conversion factor. I turned him from pounds, or her, I don't know what does it say, into kilograms. So what I know now is that I need to figure out, he wants 0.5 milligrams per kilogram. Okay, so I know this kid is 66 kilograms. I know this kid is 30 kilograms. We just figured that out. He's 30 kilograms. He ordered it at 0.5 mgs per kilogram. What goes up must come down. I'm just going to flip-flop that. So kilogram goes on the bottom, 0.5 milligrams goes on the top. I can cancel out kilograms. That leaves me with milligrams. So now I do the math. 30 times 0.5, that's the same as saying half of 30. And the answer is 15 milligrams. But they've asked me how many mils. So I got another conversion I got to do. It's a lot. Okay, so I already know 15 milligrams. What I know is 15 milligrams, coming down here, 15 milligrams. I need to get that into mils. My conversion factor, 30 mgs per mil. What goes up must come down. I'm given mgs. Remember, they're married. They can sleep on either side of the bed. So I'm going to put 30 milligrams on the bottom, 1 mil on the top. These cancel each other out. If I do my math, 15 divided by 30, that's going to give me, and I'm left with mils, that's going to give me 0.5 milliliters. That's your final answer. That's a 3-step problem. At the end, I always want to ask myself, does that make sense? Does it make sense? This kid, if it is 30 milligrams in 1 mil, and I found out he needs 15 milligrams, 15 is less than 30. It better be less than 1 mil. And it is. It's only half of 1 mil. You always got to check yourself at the end. I can't tell you how many times I've done it backwards or done my math too fast. And when I think about it, I'm like, oh my gosh, I shouldn't be giving this patient, 10 mils. It's supposed to be 1 mil or whatever. And it was just a simple mistake in my conversions. So always ask them to make sense. Okay, so that's a 3-stepper. I've got to take the weight or the mass, is technically what it is. I've got to turn that into kilograms using a conversion that you probably need to have memorized, 2.2 pounds in a kilogram. Then I have to take that, and I have to multiply it by the dose that the doctor's given me. Then I have to take that and turn it into, use the conversion factor to find out how many mils to actually give that kid. Whew. I know, that one's a lot. That's why I am ending with the harder ones. I'm going to erase again. I'll give you this video and you can go back to it if you want. If I worked out every problem in here, this would take me forever. That's why I just kind of did the intro one and then I'm doing the application ones. Okay, we only have one left. Again, application exercises, page 294. Number 8. A nurse is preparing to administer dextrose 5% and lactated ringers, which is a type of IV fluids. 1,000 milliliters to infuse over 6 hours. The drop factor of the manual IV tubing is 15 GTTs per mil. The nurse should adjust the manual IV infusion to deliver how many GTTs? All right, here we go. So what I know on number 8, the very last one, is they want me to give 1,000 mils, and they want me to give that over 6 hours. That's what I know, sorry. I know the conversion factor because it's given to me. It's 15 GTTs per mil. And then the question is, how many GTTs per minute? So right away, I need to look at the overall. It's asking me for something in minutes, but it gave me the time in hours. That doesn't make sense, right? So I know I'm going to have to convert that. I know how many minutes are in an hour, right? I think we all do. There's 60 minutes in an hour. So that's the first thing I need to do. I need to convert that hours into minutes. So you can do this in your head, I think is the easiest way. 6 times 60 is 360. So that's the same thing as saying 1,000 mils in 360 minutes. Again, all I did is I did 6 times 60 to get that because there's 60 minutes in a mil. If you want me to actually set up the conversion factor, you would do it like this. 1,000 mils in 1 hour. I'm going to keep, I'm going to keep my 1,000, my 1,000 mils. That's going to be 360 minutes. Huh? What'd you say? You're not talking to me?
Nothing. It was Jax.
Okay. All right. So I have to and turn it into minutes. So now what I know is this: 1,000 mils in 6 hours is the same thing as saying 1,000 mils in 360 minutes. I just took 6 times 60 to get it into minutes. That's all I did. Okay. So now I take what I know, and what I know is there's 1,000 mils in 360 minutes. I use my conversion factor. So what goes up must come down. Here's my conversion factor. That means I need mils on the bottom. So I'm going to set this up, 1 mil, 15 GTT. That cancels out the mils, and that's going to leave me GTT per minute. My question is asking me how many GTTs per minute. So now I just do the math. 15 times 1,000 is 15,000, but I have to divide that by 360. So again, I used a calculator. I can't remember if it was a decimal or not, but in the end, that gives me 42 GTT per minute. You always have to think, does it make sense? They want to know GTT per minute, not per hour. I better turn that hours into minutes. And we all know how to do that in our heads. There's 60 minutes in 1 hour. Okay. I worked through 8 plus another one. I taught you the tricks. Find out what the doctor's orders are, what you know. That's always what you start with. Identify the conversion factor, whether it's in the problem or whether you have it memorized or you need to refer back to your book. Figure out what the actual question is. What do they want in the end? And then at the very end, does it make sense? Before you push any drug, does it make sense? Just think, that could be my mom or dad or kid or whatever. Does 10 mils really make sense for this tiny baby? You know what I mean? Okay, that's what I have for you. What else do you need from me?
Thank you so much. I'm just gonna have to go back over and watch your video again, to be honest, because it was like so fast, and I'm just not math savvy.
I know,
but
it was like have a
I think once I watch it,
yeah.
Huh?
That's why I was like,
yeah. Once I go back and watch it, it'll click better.
Okay.
Yeah. Thank you. We appreciate it.
Sure. Anybody else? Any questions? I'll send Jill this video, and then she can send it out to you guys. And then my email is there if anybody needs to email me, and I can always hop on Zoom and help somebody or something.
Okay.
If I'm free, let me say if I'm free. Okay, you guys are amazing. Go do great things. I'm super excited for you all.
Thank you very much. You really refreshed my memory. Thank you.
Thank you.
You are so welcome. I'm sorry if I was too fast. Just trying to fit it all in. We've been here like an hour, so. Okay, guys. Bye.
Yeah. I can watch it.
Okay.
Bye.
Bye.